Okay, so next we're going to look at conditions at equilibrium and do a few example problems. So at equilibrium, Q, which is the initial conditions, equals K, which is the equilibrium conditions. The cell potential equals 0. So then if we write the relationship, 0 equals the standard cell potential minus 0.0591 divided by moles of electrons times the log of our equilibrium conditions. Rearranging that, since we have 0 on one side, the log of K equals N moles of electrons, standard cell potential, divided by 0.0591. So the first problem says we have the following galvanic cell half reactions. We are given their cell potentials. Determine the overall cell reaction and calculate the cell potential. And then we're going to calculate K for the cell reaction at 25 degrees Celsius. So in this reaction, zinc is going to form zinc cations and 2 electrons. And since we flip that, we're going to flip the sign on the cell potential. The iron, and this should be a superscript here, iron cations are going to gain 2 electrons and form solid iron. And so we're going to add these together. We're going to add down here. And so we would get iron cations reacting with solid zinc. These are going to cancel to form zinc cations and solid iron. And so this was give us a cell potential of 0.32 volts. So then we want to calculate K for this. And so this is 75B. The log of K equals the moles of electrons times the cell potential divided by 0.0591. And so the log of K equals 2 moles of electrons divided by the cell potential divided by 0.0591. So when I solve for what's on the right-hand side, I get 10.8291031. I will need 2 sig figs because the cell potential is 2 sig figs. So I'm just going to underline to keep track of that. Taking the inverse of the log is an exponential. And so then when I solve for K, I get with 2 sig figs 6.7 times 10 to the 10th. Again, I will have office hours if you have questions, or we can go over this problem.